All right, everybody, welcome back. You had so much fun in the first video, you just had to come back for one more. So thank you for being here. Let's do exercise 2. I like exercise 2 because we get to change the model. And changing the model, to me, emphasizes that these models, we get to write them down as whatever we want. So let's do it. Let's change taxes here, t, from a exogenous fixed value t bar to a endogenous function of y. So we'll have some fixed flat rate tax t bar, and then we'll also, the government will tax some fraction, little t, of total output. So it's asking us to find the government spending multiplier, which means we need to use the equilibrium equation. Well, the desired demand equation, or the aggregate demand equation, as you will. And that's going to be c plus I plus g. For all of these ISTR questions, we always just begin with this identity. And then let's substitute in our system of equations. That was a pathetic bracer. Okay. dd is going to be c0 plus c1y. I'm just going to factor the c1 through right away because we're going to need to do that. And then we're going to have minus c1t bar minus c1ty. So I substituted, in one step, I substituted this equation into here, and then I factored in c1. So maybe that's too much in one step. I apologize. Try not to do that in the future. It drives me nuts sometimes when people just go too fast and they skip over intermediate steps, and I don't know what they're doing. Okay, so we have this, and now we need to put the system into equilibrium. And we know that equilibrium implies y equals dd. So let's do it. Y is equal to c0 plus c1y minus c1t bar minus c1ty plus I bar plus g bar. And then gather the y's. So we have y minus c1y plus c1ty is equal to c0. Let's do the positive ones first, I bar and g bar. And then I'm missing c1. No, c1y goes out. Oh, yes, I'm missing minus c1t. Minus c1t bar. Okay, factor out a y. We get 1 minus c1 plus c1t y is equal to this. T bar. We can do another factor. We can factor c1 out of here. So we write 1 minus c1, and we factor out a minus c1, so that we get 1 minus t. Why? Because you know that this t, so t is a rate. We know that t is between 0 and 1. So it makes more sense to have it written like this, 1 minus t, because then this will be positive. Yes, and you know c is between 0 and 1 as well, so then this whole thing will be positive. It sort of makes more sense, at least to me. You write it however you like. And then over here we have this still, c0 plus I bar plus g bar minus c1t bar. And then we divide, and we have our multiplier. So it is 1 over 1 minus c1, 1 minus t, equals, open parentheses, c0 plus I bar plus g bar minus c1t bar, close parentheses. Okay, and I'll put a box around that because we did a lot of hard work. Now when you change a model, this is something I mentioned in the TD and I want to emphasize it again. When you change a model, it's nice to see, can you recover the original model? Why? Because it sort of lets you know that you didn't make a mistake somewhere. So if you look up here, we have this, we used this function t equals t bar plus ty. And so we know that when t equals 0, then t equals t bar, okay, so which is our old model. And so if we come down here and we plug in t equals 0, the multiplier is going to collapse to 1 over 1 minus c1, right? So given t equals 0, then k equals 1 over 1 minus c1, 1 minus t equals 1 over 1 minus c1. And this is exactly the multiplier that we got from our first model. So we know, because when we plug in t equals 0, that everything is correct. When we plug in 0, we get the old model back, so we didn't make any mistakes in our derivation of the multiplier for this new model. So great. I guess I'm out of board space, so I'm going to cut this one up, and in the next part we'll do question 2. So I'll see you there.